As our programs and projects grow in size, we need to be able to organize them more intentionally and more deliberately. We'd like to be able to separate unrelated functionalities from one another, and Python's module system gives us the ability to do that. The idea that we can separate unrelated bits of code from one another and potentially import some functionality from one place into another place in our program is common across many different programming languages and systems. And this gives us some modularity so that we can build more robust, larger programs while isolating concerns and keeping unrelated concerns separate from one another in the structure of our code. So as our programs grow in size, what we will see is that we make use of modules and packages to keep things organized. There's a direct relationship in Python between a package and a folder that your code is stored in, and also a Python file that ends in .py and a module. These two words are effectively synonymous with one another. A package you can think of as holding many modules or many other packages, and a module is an actual Python file that has definitions in it. We're only going to be looking at the very fundamentals of these concepts in this video, but in the slide deck you'll see a link to read more of the official documentation, and I would encourage you to if you'd like to write programs that make more full use of packages and modules. When we've been working on and thinking about global names, and we've seen this in memory diagrams where we have our globals frame, and when we define a function or a named constant that gets defined in our globals frame, the names that are available in a Python module for import in other modules are those that are found in your globals frame. And so this is going to give us the ability to write some functions or some definitions at the global level in one module, and then from other modules we'll be able to make use of those. You've actually probably already made use of this when running in the REPL, and you've written a command like from, and then you give the path to your module, import, and then a specific function name that you wanted to test out or try in the REPL. The same idea is at play here. You were able to import that because it was a global name in the Python module that you were writing. This relationship is manifested in a few places in textual format. So when we think about the directories and the folders in your computer, we're thinking about folder names being package names and the module names being Python file names. So if I open VS Code here, and we see that in my workspace, I've got a number of directories set up, or folders as you might call them. And in each of these folders, we've got either other subdirectories or subfolders, and we've got Python files. Well, as we've just been seeing, these directories like demos, exercises, lessons, these are considered packages in Python, and these Python files are considered modules in Python. So we're going to be looking at a module named ls_24.py today, and I've set up just a simple summation function here, or a total function is what I've named it, to be separate from the built-in sum function, and we'll come back and look at this a little bit more closely in just a minute. So the relationship between directories and modules, or packages and modules, is a package can contain many modules and can also contain many other packages. Again, this should relate directly back to your understanding of folders and files on your computer's file system. When we actually refer to these names in our programs, we need to be using specific syntax to do so, and Python uses what's called the dot operator, or just a simple period character between a directory name or a package name and a module name, or between a package and another package and a module. And so you'll see in this module path where we've got lessons.ls24_module, that's a complete module path where we've got a package that's specified first, and then the dot is separating, saying, hey, ls24 module belongs to or is inside of this lessons package. And we could have this be multiple levels deep. And you've seen this in other exercises where we've had a single exercise folder that has additional modules within it, and that impacts the path of how you refer to these different modules in your code. So where does this actually matter? Where does the module path matter? When you are importing code from one place to another in your program, you'll say something like from lessons.ls24_module, which is the path to the module, import, and then the name of the function or whatever global name that you're trying to import from that particular module. So as we've seen, the syntax that you're actually now accustomed to and have used in many different places is what you're seeing here, where we've got from module, import, and then the global name of whatever definition we're trying to import here. And the global names that we've seen are things like functions or named constants. So we've got this function, and we've seen it in the file that I just demonstrated briefly, a total function where the implementation is elided. But if we had a function defined at the top level of one of our modules, like ls24 module, then we could import it by saying from lessons.ls24_module, import, and then that name, right? And so hopefully at this point, this isn't feeling too surprising or magical because you do have some experience doing this. When you import in this way, the name, in this case total, will become bound to the exact same definition that total was bound to in the module ls24_module, right? So just to give a quick demonstration of this, if I open up a REPL here and I start Python, and okay, so I'm going to start my Python REPL, and from lessons.ls24_module. And so that is the path to the module, right? Lessons is the package, ls24_module is the module, and we're importing total, right? And so now in my REPL, the name total is bound to the definition that was defined in this module. So we've imported it, right? And we can do this from other Python files as well. We can set up another Python file in the lessons directory and have that same from line where we're importing the definition of total and make use of total in a file that's adjacent to or a sibling to this particular module. But we could try it out. So total and then 1.0, 2.0, and 3.0. We assume that the total of those is 6.0, and it looks like our function is correctly implemented. There's another way of importing modules, and you've seen this when we've worked with some third-party libraries. And in fact, this is actually an encouraged way of working with other libraries, is we'll import the entire module as a single name. And that will give us access to all of its definitions through a single entry point name that we can use to say, not have to import all of the names of a function at one time, or of a module at the same time. So the slightly different syntax here is we're going to say from package, where package is the package path. It's not going to be the complete module path, but what is the folder or the package that our module is in. And then we import the module's name directly, right? So for example, what we've been seeing here, and we've seen from the lessons package, we might be able to import the entire module, ls24_module. And then if we wanted to use, say, the total function, after we've imported the entire module in this way, we would use the module's name first, so ls24_module dot, and that dot is saying, okay, look inside this module and look for one of its globally defined names, in this case total, and make use of that function as you're seeing here. Right? So if you've used pyplot in matplotlib, it's the same concept where you import pyplot from matplotlib, and then you can use all of the functions in pyplot by saying pyplot first, dot, and then the function name that you're trying to reference inside of that module. If you don't do it in this way, if you do it in the way that we did it before on the previous slide, you'd have to import all of the names of the functions that you needed, and all of those names become names in your program that you can't then use. So we think of this as muddying up or overcomplicating the namespace of some file, of some module that you're working in. And so it's typically encouraged to use this idiom where you import the module and then say module name dot and then function name. That's the most encouraged way of importing many functions and using many functions from some other module, whether you wrote it or not. So what happens when you actually import one of these files, and what happens when Python evaluates that from line and pulls in that definition? Well, this is a process that the full details of it are more complex than we're going to be able to cover in this lesson, but the overarching steps are pretty straightforward. The idea is When you import from a module for the very first time, that entire module needs to be evaluated. That means that Python is going to say, okay, let's pump the brakes right here. Let's go load some other module and process all of its instructions one by one as we would anything else, and load all of its names into its own global space. And then when you say, okay, well, the things that I wanted from that module were X, Y, and Z, it goes and it binds X, Y, and Z in your local module that you were working in and importing to. It binds those to the same definitions that existed in the other module that's getting loaded. Right? This happens even if you're loading only a single function from some other module. The entire module has to be processed in order for Python to know exactly which definition you were using and to just be a consistent system for being able to import from another module. So when you do import in this way, the special Dunder name that we've seen many times already, the __ name __ winds up being assigned a value that's a string value that is equal to the module's path, right? So if we did this, as we saw before, the module's path is lessons.ls24 module. And this is what the __ name variable would be set to if we imported from it and when it gets loaded during that import process, right? When we run a module using the -m syntax, that name variable is set to __ main, right? And so this is why we have that conventional idiom at the bottom of our files that we want to be runnable as a module. And we say if the name is main, that means someone tried running this program directly, which is different from someone trying to import some of my functions from some other file, right? So this is a common idiom to give us the best of both worlds, where we can not only run a Python program as a module and have and run python-m and give a module path to run that module. We can also import some functions that might be or definitions that are defined in that module without the module running, right? And so this if statement gives us both of those behaviors. If we just import some definitions from this file, the main function doesn't get called and our program doesn't begin running like that. So that allows us to use functions and evaluate them from other files, and this winds up being very handy. So this is a quick introduction to modules. The key takeaways are when you define names in a module, which is just a Python file that ends in .py, those names are then importable from other files in your Python programs. And the way that you reference other definitions in other modules is by giving a from syntax, a from line, saying from some other module, which might involve a package dot module or package dot module, depending on the organization of your packages. You'll import specific names. And we looked at two different ways of importing. You can import names directly, and you can have a list of the functions that you're importing from some other module, or the list of the names you're importing from some other module. Or what tends to be preferred once you're comfortable with the idea of it, is you just import the whole module, and that gives you access to all of its names. And then you can say module name dot, and then whatever is defined inside of that module to reference it. What this gives us the ability to do is to better organize your programs, and this will allow us to start writing larger Python projects and do more interesting things.